All right, guys, lesson 38. We're getting so close to the end. So, integrals of a sum. We're back to the integrals. We're back to that silly S curve. So, if we were taking derivatives of a sum, what would we have done? We would have simply just taken the derivative of each one and added them together. It's the same for integrals. Okay, so I'm going to use that little S thing that I drew. Ooh, I'm moving the whole thing. I thought I could just pick up that one. I guess not. It's okay. So if we have the integral of some big, long equation, we'll do x squared plus, let's do some others. E to the x plus cosine x dx. Put all that in parentheses. Okay? So, the integral of all of this added together is simply the integral of x squared dx plus the integral of e to the x dx plus the integral of cosine x dx. And if you can integrate every single piece, then you can know the integral of all of them added together. Okay? So, let's do that. I'm going to scroll for just a little bit. Okay, the integral of x squared dx. Now, question is, what's the integral of x squared dx? So we have to remember that little rule of where we're adding x to the 2 plus 1 over 2 plus 1. Okay, and then there was a plus c. That's the integral, of this piece right here. Of course, I would simplify that, but I'm going to in just a minute. Let's take the next piece. Oh, I changed colors. Let me go back to blue. What's the integral of e to the x dx? Are we adding the one dividing by? No, it's the same thing as your derivative. The integral of e to the x is simply e to the x. This time we just have a plus c. Okay? That is the integral of this piece. Okay? And last, it's the integral of cosine x, whose derivative is cosine x. And we know that is sine x plus c. So the last piece here, this is the integral. Okay? And if they're all added together, we simply add them together down here. Okay? So as I simplify and put things together, I have an x cubed over 3 plus c. Well, wait, how many c's do I have? Can I put those all together at the end? Yeah, I can. Plus e to the x plus sine x plus c plus c plus c. We could say, well, that's just 3c. Think back, what did our c stand for? Okay, it was just a constant. It's just some number. It could be any number. So any number plus any number plus any number. Can I simply just put any numbers? Yes, you can. So this would be my answer for the integral of the sum. Take the integral of every piece, put the c at the end. Okay? You've got it. You guys are awesome. Let's do another one, because we get better with more problems. What's the integral of 6s to the 12th plus 5s plus 3e to the s plus 4 ds? I forget the parentheses at the front. Okay? So, what are we doing? We're taking the integral of every piece. If we want to talk about breaking them apart and pulling the constants out, because I still actually like that, this first piece, what's the integral of 6s to the 12th? I would pull the 6 out, because that's my constant, and then I would find the integral of s to the 12th ds. Okay? Then I would take the integral of 5s. Wait, I'm pulling that 5 out. I'm taking the integral of s ds. The 3e to the s, I'm pulling the 3 out. E to the s ds. What about that last one, the 4? Is that a constant? Yes, I can pull it out also. And I would just have what's the integral of d to the s. Okay? That's what pulling the constant out. Eventually, it kind of comes second nature to not do it. If you get to that point, it's okay. Starting out, I still like to pull out the constants. Okay, so I'm going to go right below and say, what is the integral? What integral do I have? So if I take the integral, I still have my 6 times s raised to the 12 plus 1 over 12 plus 1 plus c. And remember, I'm not going to put that c this time. The next piece, 5, I'm going to go ahead and put the plus, 5s to the 1 plus 1 over 1 plus 1. Okay? Next, I'm going to take this piece. I'm going to put that plus sign. I'm going to have my 3, e to the s. What's the integral of e to the s? Simply e to the s. So that one wasn't that big of a deal. And then this last one, I've got a 4. Now, what is my integral of just d to the ds? Right, it's just s. Sometimes I'll say, well, whose derivative is just 4? Well, that's 4s. If I take the derivative of 4s, I simply get 4 back. Okay? So we do know we have that plus c out here. So now I'm going to go back and simplify this because some of these I put in parentheses need some simplification. Okay? So here we go. I've got a 6. If this can't reduce, that would have been wonderful, but the book doesn't always like to reduce. So 6s to the 13th divided by 13 plus 5s squared over 2 plus 3e to the s plus 4s plus c plus that constant that we're just going to put at the end. And you're done. You got this already. It's so easy. Okay? If you have integrals, if you can find the integrals, you can do this. Okay? We're going to keep going. Let's do another one. Integral of, now remember my parentheses this time, 6 sine u plus 5u to the negative 5th plus 3 e to the u minus 2 du. Sometimes they use different letters. You see that? It's not alarming. It's any variable that you have. Okay? Now we're going to break it up. If I were to break this up, I have the integral of, I'm pulling the 6 out, sine u du plus 5 integral u to the negative 5th du plus 3 the integral e to the u du minus. Is it okay if there's a minus there? Of course it is. U integral of du. Okay? We use it all the same. You might recognize something with this sign. What's derivative is sine? You might say, what's cosine? Well, actually, the derivative of cosine is negative sine. So when we want to find the integral of sine, we have to do that adding the negative things. Okay? So I'm going to go back and add a negative to the inside and outside. That was that negative 1 and the negative 1. Okay? So before I pulled it up, I had negative 6, negative of a negative 6 sine u. That's what I've done. And I've pulled out the negative 6, and I left one of the negatives inside. Okay? That's the only tricky part with this problem. Okay? When you have that sine, integral of sine. So let's go ahead and do this. I've got negative 6. The integral of negative sine u is cosine u. Okay? We're done with that piece. It's just going to be that negative on the outside. Plus 5. What's the integral of u to the negative 5th? If I need to, I will go ahead and write negative 5th plus 1 over negative 5 plus 1. Okay? plus, we know the integral of 3e to the u is 3e to the u. What about negative 2 du? Is negative 2u. Okay, oh, don't forget the plus c, which maybe I wouldn't have done if I only had one to simplify, okay, to rewrite. So if I rewrite negative 6 cosine u plus 5u to the negative 4 over negative 4. Ooh, maybe, instead of having that negative 4 there, maybe I just make the whole thing negative. Okay? Yes, that's a much better plan. Plus 3e to the u minus 2u plus c. And we have our answer. Okay? Are we good? You are great. I'm so proud of you. All right, one thing we do have to note, what if I ask you to find the integral of x to the negative 1 dx? Our rule that says when you take the integral, you add 1 to it and you divide by that. What happens here? We have an x to the 0 over 0, which is 1 over 0. Is that possible? No, it is not, because we're going to be dividing by 0. Okay? What do you know x to the negative 1 is? At this point in time, I would rather you write it as 1 over x dx. Is there a function whose derivative is 1 over x? Think back. If you've got that cheat sheet, pull it out. It's been a while since we've looked at that. Natural log of the absolute value of x is simply 1 over x. If y equals natural log x, then y prime is 1 over x. So the derivative of natural log x is 1 over x. So when we are going backwards, and I know the derivative, can I say this integral is natural log x? And they're going to put the absolute value signs on it because we can't have natural log of a negative number. Okay? Perfect. So, and we would have our plus c out there also. So I probably would put it in a box. Let's put this in a box. Integral of 1 over x dx is equal to natural log absolute value of x plus c. That is an important fact to remember, okay? Because the derivative of natural log x is 1 over x, okay? So going backwards, that would be our rule, okay? So anytime you see something that's over, let's go ahead. We want to find the integral of 4 over t plus 3t to the negative 1 plus 4 cosine t plus 3 sine t dt. Okay, so they are going to put this in a long line of summations and say, well, let's look at each one individually. Okay, so what's the integral of 4, because that 4 right there is a constant that I can pull out, okay? 4 of 1 over t dt. They might even write it as dt over t. Okay, I don't always like that, but they will write it like that sometimes. What about 3? Integral, what about t to the negative 1? Would I rewrite that as 1 over t dt? I would, yes. Plus 4 times the integral of cosine t dt plus 3 integral of sine t dt. Okay? So now we, instead of one problem, one big long problem, we have 4 small problems. Okay? So here we go. 4 times the integral of 1 over t is simply, it's 4 natural log t. And I think they put absolute values. They do, yes. Plus 3 natural log t, absolute values. Cosine the integral is simply sine, because the derivative of sine is cosine. But this one over here is the tricky one where I have to put the negatives. So I'm going to put a minus 3 cosine t. And now I have my constant c. Now, one thing that they do in the book, if you have 2 things that are common, can you put them together? Yes. So 4 natural log t plus 3 natural log t would simply be 7 natural log t plus 4 sine t minus 3 cosine t plus c. Thought that one I wouldn't have to rewrite, but we need to combine. Okay? We're done. That is integrals of a sum and with the 1 over x. You guys are rocking this. We're almost done. We're going to do a few more problems from lesson 38. We're simply going to do 3 through 9. We're not even going to do the crazy word problem. So lesson 38, numbers 3 through 9. I think this might be a little bit longer of a video. I'm sorry. All right. Love you guys. We'll talk to you later. Bye.